from the closet.
Me either.
Sock closet. It's on our stroller.
Okay.
Okay.
So here we go. We're in the quiz.
Okay, sorry, I'm resolving a blanket issue for my kids. Okay, now I'm getting the quiz.
Vital. Don't you worry.
It's very.
It is. It's a big deal. Okay. All right. So, question.
Okay.
Introduction. Find the margin of error for a 90% confidence interval with a standard deviation is 50 and n is 25. Wish I need a pen.
Yeah, I'll need some. I'm grabbing paper. Sorry.
Okay. Okay. So one thing that with this equation, maybe I just didn't look at the example enough. It talked about using the z-score also with it. So we have to calculate the z-score and then use the equation that it gives you for margin of error. Am I understanding that correctly?
Yes. Even with this one, find the margin of error.
Yeah, I'm just looking at the equation that's at the bottom of chapter 10. And it says the margin of error gives an estimate of the variability of responses. It is calculated as m equals, and then it has z times the standard deviation over the square root of the number of samples. So I think so, but I'm not. So we do have to calculate the z-score first, and then use it that way? Am I understanding that correctly?
I'm going to jump back to the book too, because I thought it was just find the margin of error, which is well, I guess is that what the z-score is? If it's the confidence level z-score, I get what you're saying. Yeah, it's that little chart that it gives us. So if it's the 90%, then we have the designated z-score, which is 1.645.
Okay, that's what it is. All right, where's that mobile probability app? That seems to be in my existence. Where'd it go? Is that? Okay, yeah, now that makes sense. What parts should be highlighted for that? Should just be the center and the like the center and the right.
Well, for this one, we wouldn't. I don't think we would need that.
We don't need. Then we don't need the applet for it. I'm just kind of trying to understand where we're getting the z-score from.
Yeah. So, and I wanted to bring up the textbook. I was just looking over my notes with it. Week 6, lesson 10. Sorry, almost there.
Yep.
There we go.
One second.
Oh, there it is.
Okay. So did you guys figure out that one? Or I'm just trying to make sure I understand the equation correctly.
So I got 16.45, but that seems
Okay.
so simple. But I just did the formula.
All right.
No,
Where does-
that's
so
what
you
I
put
got. I got 16.45.
You put, because I'm trying to figure out, you just use the normal dash probability thing to get the z-score that's on the equation?
Yeah, I just used the chart that they gave. It's about halfway through the lesson under section 4.1.4. It's got
4.1.
typical confidence levels and the z-scores, the most commonly used one.
Oh, gotcha. All right.
So
Yeah.
that's the number that I used for the z-score, and then just plugged it into the formula.
Gotcha. All right. Because I totally forgot about that chart. I was like, what?
And it says to round to 3 decimal places, so I guess just add a 0 at the end.
Yeah.
Well, because I got at first 16.449, and then I think
Okay.
it's just 16.45. I guess you can, if it's asking
yeah.
for 3,
You're
add
just
a 0.
multiplying it by 10 because it's 50 divided by 5. So, yeah. Yeah, so really quick before I walked away for a little bit, Trevor was here and now he isn't. Where did Trevor go?
Maybe his internet cut off or something.
Okay.
So do we want to do 16.450?
Yeah, sure. You can throw a 0 on there.
Okay.
Which of the following statements is true?
For that one, I'm thinking it's the
Sorry, I
The-
just
third one.
Hey, Trevor's
Yours,
back.
Trevor?
yeah. This whole time I still thought Brian was gone. I wasn't looking at the screen. I was like, it is really silent over there.
Yeah, I was like, oh yeah, I'll be right back. I came back like 30 seconds later and I was like, where'd Trevor go? Yeah.
Are we still on 3?
We just did it. So yeah, we went to that chart you were talking about and it gave
Okay.
us the z-score there and we just did the equation. So it was 16.450.
Nice.
And now we're just on question 4.
Okay.
And you said you thought it was the third one?
Yeah, I was thinking it was the third one.
I think of the
Maybe overhearing it
these darn symbols. It's like reading hieroglyphics. I always have to remind myself.
I want to say I remember seeing that somewhere when I was reading, but I could be wrong.
I found one under 3.1. You have point estimators. This shows that the mean of the samples over the mean, which would be
Oh.
mean of the samples is the point estimator over m, or x with the line over it is the point estimator over m. I'm trying to figure that out. If that
Yeah, I'm looking at it too. I'm in the same place you are.
Okay. So it says a point estimator gives one specific value as an estimate of a parameter. And since the parameter is associated with the population, I would think that the sample mean would be an example of a point estimator
sample.
of the population or the parameter.
So like
And
the sample mean gives us an estimate of what the population is. So if we take 50 samples of every state, then that gives us a rough estimate of what the entire country thinks.
right. So I think it's the second one.
Okay.
Cool.
The sample mean is a point estimator of the population mean.
Okay.
That would make sense. Yeah. All right. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of 64 and computes that the mean of population is 526. Use this information for the next 6 questions. Okay, so the point estimate is the first thing we're doing.
So the point estimate, I believe, is the sample mean. So when you look at the lesson,
Yeah.
it gives an example in section 3.2. It gives you like a political poll, and it says the point estimate for the support of such and such is 49%. So anyway, sorry, I don't know if I'm making sense.
I'm trying to follow it.
Same.
So are you saying that the point estimate is a 64?
No, that's the number of samples. I think it's actually the sample mean is the point estimate, because the point
Okay.
estimate is a statistic from the parameter or the population. So the sample, I don't know if that's true. Maybe I'll just turn in the quiz right now.
No, you don't have to do that. Sample mean, that sounds right. The sample mean.
Yeah.
It's not going to be the.
Yeah, the sample mean is the point estimate. You're correct there.
Okay. If I'm
Okay.
wrong, then somebody else take a stab at it next time.
Okay, so what are we putting it for 5?
I looked it up somewhere else just because for some reason the reading was kind of confusing me. And yeah, it says the same thing, that your sample mean is your point estimator.
So we're saying,
then-
McKenna, we're saying it's the sample mean 526.
Okay.
Yeah. All right, margin of error. So this is the same way we just calculated it.
Mhm.
And then looking for 95%, so we have to go back to that chart that's in the lesson.
So z-score is 1.960.
Doing
Which brings it to 27.685.
okay. There's
Trevor, did you say 27.685?
Yep.
Okay, that's what I got as well.
Yep. Okay. Lower limit of this confidence interval.
So we take the sample mean and we subtract that margin of error. And
Okay.
I believe that, I think that's what it's asking us to do.
Yeah, that's right. And then we would add it for the upper.
I'm listening, but someone's
Yeah.
coming in the house, so I'm gonna mute my
Okay.
thing.
Sounds good. Yeah, and then we're subtracting the thing that we just calculated.
Oh, yeah.
So I got 498.315.
Yeah, that's what I got.
Yep, that's what I do.
And then 553.685.
I'm just adding it, yeah.
Okay, wait. So you guys got 498.335, right?
0.315.
315. And then for 8, 553.6.
I have
5 is what I thought.
I have
685.
5.685.
Okay.
Am I looking at that correct? Did I write that? Oh, it's 27. Sorry, I wrote down that number wrong. Yeah, so 553.685.
Yes.
To increase the sample size, then it would, what is it? It would decrease. The width of it would decrease if the sample size was bigger.
Yeah.
She had a 99% confidence interval. Does that raise or lower the z-score? Where's that chart again?
For number 10.
Yeah, okay, so it raises the z-score, so it would increase the gap? Yeah.
Yes.
Yes.
Red Bulb Light Company is planning to study to assess first life expectancy of light bulbs. Okay, standard deviation is 400. 95 confidence interval. Okay, what? And they want with a margin of error of 50 hours. Okay, so we're just filling in the blank on that and calculating for n instead of. So the z-score is 2.576 times, and then what was there? It should be 400 divided by whatever the square root of n is. Then our answer should be 50.
Right.
Yes.
The margin.
Yeah.
Yes.
50. That's
going to be our calculator. We're calculating for n, but we fill in the whole equation except for n. So 50 divided by 2.576. Okay.
In section 5, they give the formula as well.
Section 5. Okay.
Yeah, the broken down formula for the one we have. So you can do it too. I just
Yeah.
sorry. What section do they give that formula again? Oh, here it is.
it's
N
yeah,
equals z. Great.
5 sample size calculations.
Ah, yeah. I totally remember this now.
Wait. I'm trying to figure that out. How do you divide both sides by the square root of n when you don't have n? Oh, is it just a? Oh, I understand now. Okay.
That's correct. But because you have a policy for farmers, we have to go through them first. And whatever they don't pay or deny, then we pick up the difference because they're the primary. So now my dad has to file a claim on his truck, even though I was at fault, which is what jacked up his truck. Because his company's going to have to pay. And whatever if they don't cover the total damage to her car, then
I didn't realize that it was giving us the margin of error right in the story problem.
Yeah, it gives us the margin of error. We're just calculating for n.
Right. Did you guys get 245 point, or so it'd be 246?
Okay, maybe I did part of this wrong because I did not get that.
That's the z-score.
Oh yeah,
That-
yeah. Okay, sorry. I thought you were going to the. I have 2.576 as the z-score, but my answer is a lot higher than that.
Because
I'm gonna read it just to make sure I got it right. Um,
Yeah, so the z-score should be 2.576.
yeah.
wait, z-score, but z-score is always given to us. It's just
Oh,
the
yeah, yeah, yeah. That's what I
95.
mean. Yeah. I was just making sure that we had the right one written down. We thought that's what you were saying at first.
Oh, okay.
So the answer I got, rounding up to the nearest whole number, is 425.
Okay, yeah, that's what I got also.
Yeah, that is. I'm not getting that one.
So
You guys said 425?
yeah.
Okay, that's what I got.
Okay, so the way that I did it, Trevor, was so you write out the whole equation is, yeah, it's what Megan has up there. It's 2.576 times 400 over the square root of n equals to 50. So the first thing I did was I divided 50 by the z-score, and that gave me 19.5 almost. That's just me guesstimating, rounding for now. And then what you do is you multiply both sides of the equation by the square root of n. And when you do that, it takes the square root of n off of the right side of the equation, and it just does square root of n, or 19 times the square root of n on the other side. And then it's 400 is equal to 19 point something times the square root of n, and then you just divide 400 by that number, and then you square that number. Does that make sense?
Here, it's kind of hard to
So,
see, but
oh.
Trevor, I'm just going to show you my formula. Sorry, I know it's hard to see because it's like scratch paper on the back of it. So
now
n equals this
n
formula.
equals, yeah, parentheses, z times o divided by m, parenthesis, squared.
And then square. Yeah,
But
sorry, and that might be, I just realized.
but I think where I feel like you guys are putting in the wrong z-score, because it's what it asks is they want a 95% confidence interval.
Yeah.
And
Oh, that's right. And we put the 99% confidence interval. You're totally right. Because the 95% is 1.960. I just
Okay.
realized that's what he's talking about. Yep,
Oh,
yeah,
okay.
you're correct.
I put it in like 6 times and I was like, why is this so big? This
You were right, and we were all wrong. Okay. New formula. Okay. Okay, so you got 245.86 something, is that right?
Yep. And then with
So-
the sample size formula, you always round up, even
Round.
if it's below.
So 246.
Yes.
Correct.
Good thing you're keeping us on track, Trevor.
Yeah.
Good
Yeah,
call.
yeah. I have 246.
Yep.
Okay. Lower limit of the 95% confidence variable. So we have to calculate it first, and then we have to, yeah, because they don't give us the.
Well, okay.
Okay, so to be clear, we find the margin of error with the information we're given, and then after that, we take the sample mean and subtract the margin of error to get the lower.
I believe so.
Okay.
So it's so it's the sample mean, right? Not the
Yes.
population. Okay. What did everybody get? Because I got the nearest whole number. I got 99,002.
That's what I got.
Same here.
Yep.
Okay, and then the upper limit. $122,999.
I think when we only have to round always up when we're talking about the sample size. So the actual number that I got was 122,998.47.
Okay.
Mm-hmm.
0.47. So if this, I just don't know how far back you have to go with the rounding, because the 7 would make it a 5, which would make it a 9. I don't know.
This round to the nearest whole number, so it would just be 122,998.
Okay. Three requirements to be checked including a confidence interval for a mean. They are.
I'm seeing all of the above.
Well,
That's
yeah,
what I was
because
thinking.
4 or 3, and then it gives us, well, I don't know. And you need all of them anyway. It needs to be normally distributed. You have to know what the standard deviation is.
It's a trick question.
Yeah. Okay. I'll submit first.
Okay.
$100.
Perfect.
Okay.
We ever done that before?
I think like
Couple
one other time.
Go us.
Woohoo!
Works.
Okay,
Alright.
so tomorrow at 9 Mountain Time.
Yep, tomorrow at 9, we'll go through the second lesson. I'll put this link up now, and I'll see you guys tomorrow.
Okay, are you going to email the TA also?
Yeah, I'll do that right now, too.
Okay, perfect. Thanks.
Yep.
Thank
take
you.
care, guys. Bye.
See you tomorrow.
Yep.